9.2b is about the discriminant. So the discriminant is this number that we find from the quadratic formula, and it helps us figure out how many solutions we're going to have. So looking at our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Our discriminant is just the part that is under the radical. So to find the discriminant, all we need to do is to take b squared and subtract 4 times a times c. And whatever that number is, that is our discriminant. So let's practice one. We have y equals 2x squared minus 3x plus 1. Well, our a value is 2, our b value is negative 3, and our c value is 1. So let's plug that into that discriminant. Well, b squared would become negative 3 squared. Then we want to subtract 4 times our a value of 2 times our c value of 1. Well, negative 3 squared is just a positive 9. Negative 4 times 2 is negative 8. Negative 8 times 1 is negative 8. So we have 9 minus 8. Well, 9 minus 8 is just 1. And that is the number that is our discriminant. So you may be asking, well, why do we care about this number? So there are 3 things that can happen, 3 possibilities. Our discriminant could be positive, so we could have a positive number such as 9 under our discriminant, in which case we would end up with 2 solutions, right? We'd end up with a solution where we add 3 and a solution where we subtract 3. So if discriminant is positive, we have 2 solutions. If our discriminant is 0, then if you think about negative b plus or minus the square root of 0, well, that really just boils down to negative b plus or minus 0. Well, plus or minus 0 doesn't change anything, so we just have 1 solution when that discriminant is 0. The third case is if the discriminant is negative. So if you think about having a negative number under your square root, well, we've talked about that a lot, and that just means we have no solutions. So these possibilities, we could have 2 solutions, we could have 1 solution, or we could have no solutions. And that's what could happen. That's what our discriminant tells us. Now let's look at our graph. Remember from the last unit that our solutions to our quadratics are the same as our x-intercepts. So if our discriminant is positive, right, our discriminant is positive, we'll have 2 solutions, which means we will have 2 x-intercepts. Our graph will cross the x-axis in 2 places. Well, if our discriminant equals 0, we're just going to have that 1 solution. Well, 1 solution is just going to cross the x-axis in 1 spot. In 1 spot. So that 1 spot where it crosses the x-axis, that is our 1 solution. If our discriminant is negative, we have no solutions, which means it doesn't cross the x-axis at all. So we could draw our parabola any way we want, just as long as it's not crossing that x-axis. And notice how the parabolas that I drew, the examples, they're never going to cross the x-axis. This one's going to keep going up and up and up, so it's never going to cross. This one's going to keep going down and down, so it's never going to cross the x-axis. Now let's put all of this together, and this is our job. This is what we are going to do with the discriminant. We are going to look at the discriminant to find the number of solutions and to sketch a graph. So we have x squared minus 2x plus 4, and we want to plug that into our discriminant. So our b squared minus 4ac. Well, our b value is negative 2, our a value is 1, and our c value is 4. So let's just plug that in. We'll have negative 2 times negative 2 squared minus 4 times our a value of 1 times our c value of positive 4. Well, negative 2 squared is just positive 4. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. So 4 minus 16 leaves us with negative 12. Well, our discriminant is negative. So thinking back, how many solutions does that mean? Well, we can't take the square root of a negative number, so we have no solutions. So we are going to draw an example of a graph that is never going to cross the x-axis. So for example, this right here is never going to cross the x-axis, right? It's not touching it now, and since our arrows are going away, it's never going to cross it. Now would be a good time to pause and see if you can figure out this next one. Well, we have an a value of negative 3, a b value of positive 5, a c value of negative 1. So we'll have 5 squared minus 4 times our a value of negative 3 times our c value of negative 1. Well, 5 squared is just 25. Negative 4 times negative 3 is positive 12. Positive 12 times negative 1 is negative 12. 25 minus 12 would be 13. Well, it's a positive number, so thinking back, we can take the square root of a positive number. So we're going to have two solutions. So we just want to draw a graph that's going to cross our x-axis in two places. So here we go, 1, 2. And since our a value is negative, that's why I had it opening down. Now this last one, negative x squared minus 10x minus 25. Again, it'd be a good idea to pause and see if you can figure this out for yourself. Well, we have negative 10 squared minus 4 times negative 1. Okay, our a value of negative 1 and our c value of negative 25. Well, negative 10 squared is 100. Negative 4 times negative 1 is positive 4. 4 times negative 25 is negative 100. 100 minus 100 is just 0. Right? And if we take the square root of 0, it's just 0. So that would be our one solution case. So we just want to draw a graph that crosses the x-axis in one spot. And since our a value is negative, it's going to open down. So I'm going to draw my graph right here where it's crossing the x-axis or touching the x-axis at that one point. And that's our discriminant. It can tell us how many solutions we're going to have, and it can tell us what our graph is going to look like based on that number of solutions. Let's try one more, just a challenge problem. We want to find a value of c so that the quadratic equation has no x-intercepts. So let's think about what it means to have no x-intercepts. If it's got no x-intercepts, it's got no solutions. And the case where we had no solutions was if our discriminant was negative. So basically, if we have a negative number underneath our radical, this is going to have no x-intercepts or solutions. So let's just see, let's just start. We'd have our b squared minus 4ac as our discriminant. So let's plug in what we have. B would be negative 8, so we have our negative 8 squared minus 4 times our a value of positive 2 times whatever c might be. Well, negative 8 squared is 64. Minus 4 times 2 is negative 8 times our c value. Right, so we want to take 64 and subtract something so that we are going to get a negative number. We want this to equal a negative number. So whatever 8 times c is, it has to be bigger than 64. Well, since 8 times 8 is 64, our solution can be anything bigger than 8. It could be 9, it could be 10, it could be 20 or 40. As long as it's bigger than 8, it is going to cause that discriminant to be negative, which is going to cause us to have no x-intercepts. So I'm going to pick 10. If we have 64 minus 8 times 10, 64 minus 80, well, that would be a negative 16. Well, since it's negative, we've got those no x-intercepts or no solutions. Alright, so again, just to wrap up for our discriminant, we're just using it to figure out how many solutions and what that graph might look like.